A quick word from our sponsor, Build Equinox manufactures the CERV smart ventilation system in central Illinois in its 100% solar-powered facility, which is being verified as a zero-energy capable facility. The CERV is the first smart ventilation system for residents and has active monitoring and control of indoor air quality, measuring carbon dioxide, total volatile organic compounds, VOCs. With the CERV's IAQ sensors, filtered fresh air is delivered to your client's home when they need it. The CERV saves energy with its efficient heat pump energy exchange technology. Not only that, but this allows the CERV to actively heat or cool and dehumidify incoming fresh air. This makes the CERV ideal for any climate, whether hot, humid, or cold. CERV ICE connects the serve online, making it even smarter. This enables online monitoring and control of a serve from any internet-connected device and provides information on the home's indoor air quality impact on the occupant health, cognition, and sleep. Don't just ventilate your client's home. Make their house a healthy house with this Serve Smart Ventilation. All right, well, I'm real excited to welcome you to Realize, a new model for mass customizable net zero energy retrofits. This course is approved for 1 hour in continuing ed, GBCI, AIA HSW, AIBD, Certified Green Professional, NARI Green, and may be applicable to your state-based or design license. Today I will be your moderator. My name is Brett Little, and I am the Executive Director here at the GreenHome Institute. GreenHome Institute has a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. So very excited to introduce you to our speaker today. Martha Campbell is a manager at Rocky Mountain Institute, or RMI. She is working on the Realize initiative in the Residential Energy Plus program. The project is focused on catalyzing the mass production and offering of carbon neutral retrofits for U.S. multifamily and eventually single-family homes. Martha has also worked closely with the City of Fort Collins on developing new business models to accelerate its greenhouse gas emissions reduction goals. Martha joins RMI from the University of Michigan, where she earned dual master's degree in environmental science and business administration. Martha's professional experiences are as varied as learning green building techniques as a construction intern from renegade eco-architect Mike Reynolds. Working with the Rio Tinto's, I may be botching that, Sustainable Development Team, field organizing in northern New Mexico for the Alliance for Climate Protection, and program trading in the Equities division of Goldman Sachs. She holds a BA in International Relations from Stanford University and hails from El Paso, Texas. So with that, I will turn it over to Martha and take it away.
Thank you, Brett, and thank you everyone for joining today. Brett gave you a little bit of a sense of what Realize is about, but just to kind of let you know what the deal is with the actual name of the project, it's a little bit of a play on multiple concepts. So you've got real, like real value, real estate, and then the bolded IZE kind of represents this idea of catalyzing the market using industrial techniques, so industrialized, and then some people even like to think that the ZE is referring to the zero energy aspiration or zero carbon aspiration of our work. So just to kind of give you a little bit more of a sense of what we'll talk about today, I'm first just going to describe the concept in a little bit more detail, and then we'll talk about a feasibility study that we conducted to see, you know, is this idea tenable in the U.S. market? It's already operational in the Netherlands. And then we'll conclude with talking a little bit about where we are in terms of trying to operationalize and actually implement this concept in the U.S. market. So this is a picture of an actual roof going on to a set of multifamily buildings that are being retrofit in the Netherlands. So just giving you kind of a sense of some of the techniques that are being used. So in a nutshell, the goal and mission of Realize is to create a business model that replicates that which was developed in the Netherlands by a group called Energiesprong. And basically what they've done is they've used, semi-automated, industrialized techniques to allow for mass customization of net zero energy retrofits for the affordable multifamily housing market. And the idea there is that you can aggregate significant demand across the multifamily housing segment, and then you present that demand to industry, who then kind of innovates these kind of pre-designed solutions that can be produced and installed much more quickly. So we want to bring that model to the U.S. So just in terms of how this kind of looks from the customer's perspective, the offering is focused on kind of four main things. The first one is just that it's a high quality retrofit that's inclusive of a performance guarantee. In the Netherlands, they've been using a 30-year performance guarantee. The idea is for this to be relatively non-intrusive so that, you're not really displacing tenants, especially in the affordable housing market. And so, these need to be installed rapidly. I think they've gotten it down to even 1 day in the Netherlands before they've done a 1-day retrofit. But the idea is to keep it to under 2 weeks. They need to be affordable. The hope is that these can be ultimately financed over that 30-year period through the energy savings, so that the building owner basically experiences kind of a bill neutral set of implications for the cost of doing the retrofit versus paying their business as usual energy bill. And then lastly, these should be attractive. They should be desirable, and you should, be able to tell that something has happened to the building that kind of creates a contagion effect and continues to propagate the desire for these retrofits in a community. So what we did when we heard about this model, there was a lot of skepticism about, prices of electricity and natural gas or energy prices in the Netherlands are much higher than in the U.S. This just isn't going to fly. So what we did was we said, okay, well, let's kind of look at what budget would we have to work with in the United States? What price point do we basically need to get a retrofit down to for the various U.S. markets in order for this to be viable? So we asked ourselves kind of, 4 questions kind of focused around this feasibility issue. So first of all, what is the level of savings currently able to be financed with a 20 and a 30-year annual energy savings calculation? So taking the NPV, the net present value of all those energy savings, or the present value, I guess I should say. The second question is, which markets offer the greatest entry point? So, energy prices and energy spend vary by climate zone, and we wanted to get a sense of this. The third question was, what is the current average cost of a net zero energy retrofit? So we're doing 2 things. We're saying, one, if you take all of those cash flows of energy expenditures over a 20 and 30-year period, what's the present value of those? So that's kind of your budget to work with if you were going to finance a net zero retrofit with that annual energy spend. But then at the same time, how much does a retrofit cost right now? And so the fourth question is, what is the difference between those costs versus those savings, the present value of those savings? And, how far do we have to go? How much do we have to reduce the cost of a retrofit by in order for this to be tenable? So basically, I just wanted to show you a little bit of the climate zone definition that we're using. We use the climate zones that are used for RECs and CBECs, I believe, and this kind of shows you their representation. So climate zone 1 represents kind of the coldest, most northern parts of the U.S. Climate zone 2 is kind of the southwest, the dry, hot and dry climate zone. Then we've got climate zone 3, which is in the deep south, the hot, humid, and then climate zone 4, which is kind of that, that mixed humid, but also has a little bit more variability in the winter. And then climate zone 5, lastly, is kind of the maritime climate. So keeping that in mind, you can see the present value of kind of the average energy spend for the multifamily market segment across these climate zones. So the blue represents kind of the 30-year present value using a 4% discount rate, and then the red represents the 20-year present value. Actually, I think this is using multiple, I apologize, it's using multiple discount rates. But the largest number, or excuse me, the longest bars, okay, so this green and purple represents the 4% discount rate. So it's showing you that climate zone 1 has the largest average energy spend, you know, over the 30-year period. This is the budget that you would have to work with, so about a $45,000 budget that you would have to work with for doing a retrofit. Basically, this is showing you kind of the climate zones that have the highest energy spend, and in our mind, those are kind of the most desirable climate zones to start in because you have more energy spend to work with that you would be displacing by doing a retrofit. So that's kind of, yeah. So there's.
But I do have a quick question on this too. I'm looking at climate zone 5 here. If I understand right, climate zone 5, a heating and cooling zone, I'm very surprised to be seeing these low demand for energy. Am I reading that correctly?
So remember, climate zone 5, and people often get confused because they're used to using, I can't remember what the other climate zone category, I think it's like the AIA climate zone categories are different than these. Climate zone 5 is California, Oregon, and Washington. And so very temperate climates, especially obviously in California. So that's why the energy spend is quite low there. And they also have more robust, you know, efficiency standards in some of those states. So climate zone 5 is definitely tricky. So continuing on here, we said let's look at, you know, let's figure out how much does a retrofit cost in a specific market. So we know how much on average folks are spending. Sorry, let me just also make one clarification that I just realized is it got cut off here on this chart with these with this key. Sorry, so what I'm pointing out to you, it's not that there is a different discount rate. The green bar and the purple bar are the top quartile of inefficient housing for that climate zone. So the blue bar and the red bar are kind of the average, right? In the, let's just say the upper Midwest to the Northeast climate zone. That's climate zone 1. This is kind of your average spend, the red and the blue bar. Your top quartile of inefficient housing has an average spend in, you know, up to $45,000, you know, for a 30-year present value, and up to about $35,000 for a 20-year present value. So just to clarify there. So when we're looking at New York, we wanted to find out, well, great, we know how much energy spend is occurring on average there. How much does it cost to do a retrofit on average? Very high level. So what we did was we used NREL's Building Energy Optimization tool, BOPT, and we kind of took these prototypical buildings from the DOE by climate zone, and they have kind of, you know, different definitions of what a baseline building, the building attributes, as well as the systems that are in the building. So we used that kind of DOE prototypical building for our baseline, and that included a 23-unit apartment building. It was 3 stories, and we used like I said, the top quartile of inefficient housing. So in BOPT, basically, it allows you to kind of select different measures are, that you would want to, to update in the building, and it kind of shows you an optimization curve of where you basically maximize savings versus cost. And you want to be where this little kind of blue, blue circle is, in terms of which package and which set of measures that you select, for retrofitting the building. So we took that, and then we basically, and this kind of shows you kind of the baseline set of measures that were in place, and then what we replaced them with, and kind of optimizing using the software. In New York, we were able to achieve, just doing efficiency measures at this point, a roughly 52% CO2 savings. So you can see we modified things in the walls, the roof insulation, the windows, air tightness, space heating, water fixtures, hot water distribution, central hot water, lighting, refrigeration, dishwashers, clothes washers, dryer, and cook stove. So we kind of did major plug loads and then some pretty significant envelope measures. From there, we basically wanted to understand what the differential is, and this is kind of a dense slide, but on the left, what we're looking at is what is the present value of 30 years worth of business as usual energy spend for that building. So it's, if you didn't do anything, you would be spending roughly $825,000 in today's dollars on energy, on natural gas and electricity for this 23-unit building. Comes out to roughly $36,000 a unit. So then we calculate how much does the deep energy retrofit cost. That's about $644,000. So then you still have some sort of a remaining utility bill after you've made this retrofit. That's still going to be around $536,000. So then what's your new position, in terms of spend after you've done a retrofit and you're still paying utilities? It's that $644,000 plus the $536,000 of utility bills you're still going to be spending. So you're going to be spending $1.1 or $1.2 million over that 30-year period if you do a retrofit and continue to pay your new utility bill. So you went from paying $36,000, per unit to now $51,000 per unit. So it costs an additional $15,000 per unit for the utility, for the homeowner or the building owner to do this retrofit. That's just doing efficiency improvements. So, but then we want to take this to net zero. So in our scenario, we basically included as much rooftop PV as we could get on this building, and this is in the New York market, and that wasn't enough to take us to net zero energy, so we basically added an additional kind of community solar scenario, which you can see on the right. So, and then here in this purple box, we kind of have the assumptions about, what the system size was and the efficiency level and the cost per watt. And just so everyone knows, this is not including, kind of local or state incentives for solar or efficiency, except the ITC for solar. So kind of with the solar included, the economics improved dramatically. So you've got your, your cost of your efficiency measures, which was, $644,000. You've got the cost of adding your solar systems plus the community solar, so that came out to $265,000. So the whole kind of retrofit package was $909,000, and then you have this remaining fixed charge on your energy bill of $4,000. So, you started out paying that baseline of $36,000 per unit on utility bills. Now you're around $40,000 per unit. So it's an additional $4,000 per unit, or $88,000 for the entire building over a 30-year period. And so while this isn't bill neutral, this is certainly attainable. This isn't within reach. If you start to add these kind of more standardized industrial solutions to how you conduct a retrofit, we believe it's tenable to get the cost down where this could actually be, revenue positive for a building owner. So in the Netherlands, over a 3-year period, they were able to reduce the cost of the retrofit by over 40% in a 3-year period. So we see this as definitely within reach and feasible.
Martha, how did that incorporate, potential rising costs in utilities?
So we took EIA data, and we basically calculated kind of what historical, price increases had occurred in both electricity and natural gas, and we incorporated those into our future predictions of business as usual energy prices. And I can't remember off the top of my head what those averaged out to be for electricity versus natural gas, but they were actually quite modest. So it doesn't have aggressive assumptions about the acceleration or increase in prices for electricity and natural gas.
And another question was, it looked like you had mentioned there was spray foam insulation involved in some of this. Is that correct?
If that was on the list, that is the case.
Yeah. There was a specific question, and maybe this is taking it pretty far, but did you consider under any of the, offsetting the global warming potential of spray foam, or was this purely focused on energy usage?
So you're saying like the kind of life cycle, energy implications of using spray foam? Did we?
Yeah, or anything that would have, higher impact.
Yeah, we did not account for that in this analysis. I'd say that that's, our aspiration, and we are in the midst of doing this exact study for the San Francisco market. We're working, very closely with the city of San Francisco. And so, we are trying to take that into consideration, but in this specific, kind of feasibility analysis, we did not do that.
Thank you.
So this is just kind of a list of the, the cost breakdown of the measures and where the majority of the costs lie. And you can see, solar PV was a big chunk of it, the appliances, and then, the heat pumps. But this kind of gives you a sense. The reason we wanted to show this is we can take this to, manufacturers and basically say, how can we work with you to bring some of these costs down? And where are the kind of the highest percentage of costs in the retrofit package? Okay, so where are we now? We have the concept. We have the high-level feasibility analysis that says, hey, this is worth doubling down on and giving this a go. So the next thing that we did was we had a convening with manufacturers and a few kind of building agencies in the state of New York. And we talked about the different elements of this business model that need to come into existence and kind of how do we work together to do this. So kind of outlining what the components of making this thing fly, there's, the aggregation of demand. You've got your demand and your supply side. So you've got, like I was saying, the Energiesprong folks in the Netherlands, what they did strategically was they pre-aggregated demand from multifamily affordable housing owners. And they took that demand and they presented it to suppliers and said, can you develop a technical solution that operates in this manner and that allows us to make this kind of offering? Remember, that's that kind of under 2-week installation process that's not disruptive and that can be kind of mass customizable and quickly installed on site. And so, from there, there's also these components of the business model that include a financing structure that's easily replicable, that might have multiple products that vary by kind of the needs of the building owner, and that also incorporate, some of the contracts that will be necessary for fulfilling that performance guarantee. So that all has to be figured out. And then there's also, just the reality of what can you do on the ground, and you have kind of local, codes and regulations that really do preclude certain things from being possible to be installed on site. So one example of that might be, you need to work with, the planning and zoning, department in a community you're working in to change kind of what's possible in terms of, let's say in New York, you want to apply this external facade, and there's a specific term that I'm blanking on for this, but when the facade's kind of extending over the edge of the property, and like these easements and setbacks that are, codified in building code of what you can do and what's allowed to hang over and not hang over. So those are the kinds of modifications that need to be made at the regulatory level. So all of these things kind of need to be happening in conjunction with one another for this to fly. So at present, I would say RMI and its partners are working on the demand aggregation side, and we're also working on the supply side and the technical solution, and I'll talk a little bit more about that. We have started to, to dig into the financing piece, but we haven't kind of taken on that full force, but we are simultaneously working on that. But we will be focusing, like I said, on demand and supply and kind of deploying that in pilots before we kind of pivot and really get the contractual arrangements and the financing fully established. So I won't, there's a lot of text on here. I'll kind of give you the highlights. This manufacturer convening was really great. What we did, we had folks that, manufacture, HVAC solutions. We had, envelope manufacturers and panel manufacturers at the event. We also had folks from the finance side. We had the state of New York was there, San Francisco was there, Vancouver was there, and then we had a few kind of public housing agencies there as well to kind of really demonstrate to the manufacturers that the interest and the demand were there, and New York kind of presented kind of what's the market size, what's the market opportunity. And so the results after, talking about, what's the market potential, showing the results of our feasibility study were that everybody was on board with this idea and really wanted to be involved. But there was also kind of this recognition that part of this offering requires kind of a centralized coordinating body. And that right now it's unlikely that just one manufacturer is going to, offer this entire suite of components of the offering. So we, see this as kind of an opportunity for us to play that role. And that's inclusive of, Rocky Mountain Institute and our partners, including the Net Zero Energy Coalition and Passive House. And so where we're at right now is we are applying for grant funds and philanthropic funds to really focus on kind of showing the market how to do this. We're not saying that we have the answer, that our technical solution will be the one technical solution, but we want to kind of like, break trail in terms of going through the entire design process, all the way to having that design process feed into a manufacturing system and a streamlined delivery process that helps the industry kind of see how all these things fit together, and then simultaneously creating those other components of the offering, like I was talking about, the financing piece, the warranties, and making sure that there's kind of a centralized actor that can allow other players in the market to plug into. So that's kind of where we're at. we'll know hopefully in the next few months if we've won some of these grants and awards to move forward with this. But everybody recognized that kind of centralized role was really critical. We are also hosting a convening in San Francisco to do something quite similar to what we did in New York, but this next convening will be very much focused on bringing a lot of building owners together and housing agencies together, socializing this idea with them, starting to do the kind of pre-aggregation of demand process, and then also having a second meeting where we'll be working more with the supply side to say, how do we operationalize this business model in the Bay Area market? So that's kind of what's on the horizon after the first manufacturers convening. And then I have just 3 more slides kind of talking a little bit about some of the specifics of where we need to kind of iron out some kinks. And so I'll start first with the financing solution. And without getting lost in the weeds on some of the details here, but with affordable housing, and not just with affordable housing, but there are many different products we could potentially offer to finance this type of technical solution. And, at the end of the day, in our modeling, we showed we need to have a cost of capital that's like somewhere around 5 to 4%. And when you're using kind of energy service agreements, and kind of, more customized products, the cost of capital starts to immediately go up. So we said, okay, we need to really focus on kind of the refinancing, capital pool. And so that's where our focus has initially been. But what that means is that the opportunity has to exist for the building owner to kind of to capture the saved cash flows from their tenants who are going to basically be paying lower utilities. And so, obviously you have a master meter where, everybody's just kind of getting charged some amount of rent per month, and that's inclusive of their utilities, and that's a really easy solution because then, the building owner just kind of recoups a lower utility bill because they're paying the utility bill on behalf of their tenants. But where it starts to get really complicated, especially in the affordable housing market, is when you have sub-metering. And you have what's called a utility allowance, which it's not actual money that's given to the tenants to pay their bills. It's a percentage of their income past which they can't pay for utilities. And so there's a whole set of calculators that each state uses in order to determine what this kind of maximum utility allowance should be, and landlords can't really dig into taking more of that utility allowance for rent. In California, they've overhauled how they do these calculations to allow for more flexibility for energy efficient buildings, but in New York, this has been kind of a dicey subject, and so doing that kind of reform to their utility allowance calculator might prove to be complicated. So we're, with that in mind, we're having to take this into account in terms of how we structure the financing for the New York market. So that kind of gives you a flavor of kind of some of the nuances specific to the affordable housing market that we are navigating at the moment. This next slide is also kind of, sorry, did you want to say something?
Well, I was wondering if there's been any thought to the idea that tenants who are aware of their energy use might be able to be more proactive or being charged for it in reducing it, and how it would fit into this overall picture, other than obviously the challenges of the lender being able to charge more rent.
So you're saying kind of, would we want to target the tenants as opposed to the building owner because they're the ones paying the utility bill?
Well, obviously the tenants aren't gonna pay for structural improvements. That's right. Impossible. But if the whole program took a step back and said, look, if the tenants are paying their bills and they're aware of it, they may be more encouraged to reduce their energy even further than if they had no clue what their bills were, and the owner was paying for it.
Right. So I mean, in that situation, what we're trying to do basically is where you have kind of a master meter where that's occurring, right? The tenant has no idea what's going on, you know, with the actual energy performance of their building because they don't, or their unit because they're not paying for it. I think in that scenario, and this is kind of, we're not there yet, right? Where we would be thinking about what are the automated ways that we can help a building owner kind of incentivize the right kind of behavior in the tenants. And so I don't have a good answer for you yet, because then, you know, you're starting to enter into like, do we want to basically install sub-metering? But then where you have kind of a little bit of a tension is then the building owner isn't the one who's actually getting to kind of pocket that cash flow of savings, right? Because you know, all of a sudden the savings are going to the tenant, and so then you lose that incentive by the building owner to do those, like you said, those kind of more full building measures. So I don't think I have a good answer for that question, but we recognize that, you know, the behavioral aspects of meeting the performance guarantee will be required, and we basically kind of need to sit down with our counterparts in the Netherlands and really understand how they are managing this kind of behavioral and unit occupant issue with a performance guarantee that I'm assuming is kind of at the building owner level. And so I don't have a great answer for you for that, because we just aren't there yet.
Thank you.
Mm-hmm. So this next slide is kind of just showing some thinking. At this event we had in New York, we kind of split up into a few groups, one of them being the financing group, one of them the demand aggregation side, and one the kind of supply side solution. And, you know, this kind of just shows you what we're currently considering as, you know, the value proposition to building owners. We definitely need, you know, full-blown commitments. That's what that kind of actual demand bucket shows. We need full-blown commitment from certain building owners to present to the supply side, but then we also kind of need this pipeline of demand that we're continuing to accumulate. And as you can see, you know, there's a variety of different kind of value propositions that are being considered, but these are a few of them. Everything from them meeting their, you know, performance targets on their GHG goals, to tenant comfort, to just kind of lower maintenance and operating costs for the building owner. You know, New York REV is happening in the state of New York. I don't know if folks are familiar with that, but that's kind of reforming their actual utility regulation system, at least on the electricity side in New York. And so a lot of what New York REV is doing is trying to create a regulatory structure that allows for a lot of new business models to bloom around energy. And so this would definitely fit within that category and could potentially be a very strong program that utilities could support in New York. And then last point on the bottom, which I think is important to highlight, is that, you know, in the beginning, we definitely want to piggyback these upgrades on major capital improvements that are already going to be happening to a lot of these buildings. You know, the building stock is pretty old. It's pretty, there's a lot of deferred maintenance happening, especially in, you know, the New York City market, where you just, you know, these buildings are you know, expensive to upgrade, but there's also just kind of a shortage of even the trades to quickly do this work, which is a serious constraint in the New York market. So lastly, I won't get into the weeds on this slide, but what I'm hoping to kind of convey here is we had a bunch of kind of technical experts in the room at this at this event as well, and kind of some of the big ideas that came from that group were we want to do kind of two major components to how we think of designing this kind of mass customizable set of solutions. One is this like kind of HVAC mechanical, or like the mechanical system package, which we're kind of calling the magic box. It would have, your heating and cooling and your ventilation system incorporated into it, as well as your domestic hot water systems, your, potentially PV inverter systems, all kind of pre-designed for specific load profiles that would be standards that were set by our partner, Paso. So you kind of, predefine here what the standards and load profiles need to be for, the specific climate zone, specific building typology. And then here is kind of a predefined mechanical solution for that. At the same time, that magic box needs to plug and play very easily, with an envelope retrofit solution. And kind of how do we design the envelope retrofit solution appropriately for, a specific climate zone and building typology. So that's going to be kind of what the core of our focus is for two markets, the New York and San Francisco market, to kind of try and develop those standards with Passive House, develop that magic box in partnership with manufacturers, and then have a process for the envelope design and fabrication that plugs and plays very easily with that kind of mechanical set of mechanical systems. So that concludes kind of where we're at right now. I think I've given you kind of the up to the moment of what we're embarking upon, but I hope this gives you a sense of what we're doing, kind of the concept, and I'm happy to take questions now.
Great, thanks, Martha. I see a lot of questions rolling in already, and please start putting some more in. And right before we get to the questions, for those of you looking to get your continuing ed, make sure to check your email spam folder at the end of this session, and the survey that pops up at the end of the session. Please take that. For those of you watching on demand here on the recording, please take your 10-question quiz with the 80% passing rate. And then as those questions are rolling in, just again, a real big thanks to our sponsors, Build Equinox, Sun Intuitive, Niagara Conservation, Panasonic, and Air Renewed by Certainty, along with our members, board of directors, volunteers, presenters, and all of you. We couldn't do it without you. So yeah, I see some questions rolling in. I see two that I kind of want to bundle together here. I think go hand in hand a little bit, and one of them was going back to that chart you had shown us where it sort of broke down the costs and I believe energy saved, or maybe it was just general cost, but it was a pie chart from out of the New York project you showed us, where it was saying the cost of each system, solar, mini splits, insulation. And the question was, they were wondering if you had the same version of that chart, but broken out in regards to energy savings, not cost. And then on top of that, did you look into increasing any of those energy efficiency measures, such as triple pane windows, and spending less on solar, which seemed to be a big portion of that chart?
We don't necessarily have a kind of measure by measure energy savings. We started to try and do, like a McKinsey cost curve kind of style thing, but the problem is that does miss some of the interactive effects of the various measures when you just kind of take their, what VIAP basically spits out as their saved energy. And so we decided to kind of step away from that. So I don't have that available right here, and I don't necessarily think it's the best way to try and look at the savings on a measure by measure basis. In terms of, the solar component, so just to remind folks, we first did the kind of energy measures optimization first. So we took the package that BOP spit out was the optimal package of costs relative to energy savings and CO2 savings. So that's that, like I said, that's that spec on the bottom of this slide with the blue circle on it. As you start to try and squeeze more savings out, your additional costs, for squeezing out a little bit more savings go up on the right side of this curve. So we optimized the efficiency measures first, and then we took the load balance and we sized the PV to meet that remaining load balance. Does that answer the question?
I think so, but we will see. They're certainly welcome to follow up. Looking at, are there any opportunities if folks want to work with you in other markets, such as, I'm just going to throw out some names, Chicago, St. Louis, Detroit. One of the questions here from our speakers here was in something they have going on in Jacksonville, or attendees Jacksonville, Florida. Would there be any interest to do any work down there, or is your primary focus right now in California and New York?
So I guess there's definitely interest. I mean, we want to scale this model across the United States. That being said, we kind of have to start somewhere and kind of learn by doing, and then figure out, like I said, go beyond just doing prototyping and pilots and really get to the point where we have a full offering that we can take to other markets in the U.S. I would say in starting kind of with New York, it opens up a lot of the Northeast and kind of upper Midwest to us. With California, there's just a lot, and both of those markets have a lot of momentum. The state of New York is very much on board, where they've got their, 80 by 50 climate goals. They have the regional greenhouse gas initiative, and they have a lot of revenue from that they can devote to this program. So there's some reasons why we're focusing on those markets initially, is because of the resources that are available and the momentum in those markets. But I would say, if that kind of momentum and those resources exist in somewhere like Jacksonville, and I don't know if Jacksonville has PACE financing, they might. Those are markets that, and as you saw, that climate zone also has very high energy usage on cooling. That might be a market that we would pivot to after we kind of get these first two up and running.
Mm-hmm. I'm really glad you mentioned PACE, because I was going to bring that up. It sounds like you're going to be, is property assessed clean energy. I know there's two different entities, and then there's local entities state by state, but is that one of your partners rolling this out?
Yeah, so we're looking at how could we use PACE, as a financing product for this offering, and so that's definitely, it's definitely available in the state of California, and so it's something that we'll look at as like I said, we might need to have a variety of different financing solutions depending on the needs of a building owner. But PACE is definitely something that we are looking at how we could apply it to doing this kind of a retrofit, and in a way that allows us, because part of the problem right now, I would say, with all of these projects, is every single one is like a special snowflake, for how they financed it, and that's just not scalable. So we're definitely looking at how can we kind of standardize even the financing for these solutions, so that you get those transaction costs down, and the kind of the work that you have to do in advance of the retrofit doesn't take as long. So yes, PACE is definitely in the mix.
Great. Now, one of the things you mentioned is trying to get under a 2-week turnaround and getting this work done. But do you have any costs associated with trying to get a faster turnaround versus slowing it down a little bit if need be and reducing the cost?
I don't, unfortunately. I mean, I think what we've seen in the Netherlands when they got the total overall cost of the retrofit down by 40% in a 3-year period is that the more quickly you can do this, you know, the more it reduces your overall cost. So that those costs are inclusive of labor and installation costs as well.
And then going back to the financing, it just popped up. What about OnBill financing as a mechanism? I believe there's some of that going on in New York. I know we have some of it rolling out here actually in West Michigan. Is that another potential tool that you've thought about?
Yeah, you know, I've looked a bit at OnBill financing, and the state of New York has a pretty robust program that's, you know, kind of financed even through NYSERDA. NYSERDA kind of goes out to the secondary market and can raise more capital for those programs. The only limitation there, as I understand it, is that utilities cannot issue more than, I think it's like 2% of their annual revenue for OnBill financing. So there is kind of a cap in terms of the pool of funds that are available through the OnBill mechanism. Not that we'd necessarily hit that 2% mark right away. I really don't know where those utilities are in terms of hitting that 2% cap, but that's a very real constraint.
Now, what happens, you're talking about these older buildings in bigger cities where a lot of times you run into either mandated historic requirements, which can directly get in the way of energy efficiency, or they're trying to get you know, tax incentives for meeting historic requirements. How would you work with those kinds of challenges?
Yeah, that's a great question, and I think what we're trying to do right now is, like I said, we're focusing on the affordable housing market segment first, and there's a couple of reasons for that. And one of them is that a lot of the time those building typologies are pretty, they're very consistent. So like when you go to Alphabet City in Lower Manhattan, and you go out to Queens, and you go out to Brooklyn, you have all of this affordable housing that looks identical. And it's you know, these red, you know, 15 to 20 story high-rise buildings that don't have a lot of kind of you know, exterior complexities on their facade, and they would be a very easy typology to create a retrofit solution that's scalable across, you know, the 5 boroughs, and potentially, you know, beyond that in other parts of the state of New York. So we're trying to kind of start first with some very basic building typologies, but also building typologies that are not historic buildings that have a lot of this red tape, and that are kind of generic, and that you see in a lot of other kind of parts of that climate zone. So we're kind of trying to identify kind of more generic, easy to kind of standardize the process, especially as we start this, right? As we learn over time, we can maybe incorporate more complexity, but right now it's pretty generic building typologies.
Great. So there was a follow-up question to the whole energy efficiency solar conversation we were having, and that is, it is still unclear to me if BOP optimizes the costs of efficiency measures taken into account for the costs of PV. Is this the case?
So I guess, okay, so I think the question is kind of like, can BOP tell when you hit this inflection point where the cost of efficiency, you know, the marginal cost of efficiency is greater than the marginal cost of solar? And as I understand it, we took that into consideration. I don't know if BOP did, but that's probably not the best answer in the world. But our logic was that we should not be continuing to install efficiency if the additional cost of that efficiency improvement was greater than the cost of PV.
Yeah, and I think that gets me into the next question I have, and that is obviously Passive House is one of your partners, but you're not necessarily, in this case, from what you just said, aiming to hit all of the Passive House standards, because sometimes you just have those diminishing returns, correct?
Well, I mean, they just, and again, this is kind of getting outside of my area of expertise, but as I understand it, they are definitely starting to make their standards like cost optimized standards. And so as I understand it, they've been updating those standards so that they're not basically encouraging measures that are more expensive than the cost of PV, but or that are not cost optimized. But I think, that's a question to be directed to Passive House on how they do that. I will say that our partnership with them is going to develop a set of standards that are specific to this offering. They will be a special set of standards that we co-develop with Passive House for the Realize solution.
So besides Passive House, would you be willing to share some of the other technology partners? And then also a question here, what does someone do if they want to become a technology partner?
I think, just reach out to me and we can, we can start that dialogue. We're still kind of in the midst of setting up. So one of the things that the folks in the Netherlands said was a little bit of an issue initially were, that a lot of these manufacturers and private sector actors, were like, I'm not going to share information with my competitor. And, there was a little bit of this kind of like, I either get all of it and you work with me, or I don't want to play. And so they had to create a structure that was a safe place for these competitors to come and share information so that they could all innovate more rapidly and not get too hung up on the market share piece, because if we really figure out the technology, there's just a huge amount of market potential for this, and there'll be plenty of food to go around for everyone. So we're in the midst of figuring out what that structure needs to look like for our market, and like kind of assessing from industry, getting their input on what do you need to feel safe to do that kind of sharing. So that's where we are on that front. I would say, we've kind of already started socializing this idea with Mitsubishi, Daikin, Kingspan Panels was at the event. We've reached out to Renew Air. I'm going off the top of my head here, and I have a more full list that I can share with whoever wants to email and is interested. I'm just trying to think of Roxel, was there. So, and there's, like I said, there's a few others, but we have a relationship with SEPA, so they're aware of what's going on, and we want to leverage them to kind of activate their membership to start innovating solutions. So anyhow, I hope that kind of answers the question, but we are definitely open to actors in the market that are interested in innovating and being part of developing the technical solution, and we're working on creating a structure that allows them to do so in a collaborative way that moves us along more rapidly.
All right, great. Well, it is now 1 o'clock Eastern here on the live session, and I don't see any other questions, so we're going to go ahead and wrap up. I really hope that we'll be having you back in a year or two to go over some real-world success stories. I'm really excited to stay in touch with this program and help others continue to be able to utilize it. And before we wrap up here, Martha, where can people find out more information if they want to contact you or if they want to learn more?
So my email is just right here on this last slide, mcampbell@rmi.org. We are in the midst of kind of updating our website. I will be honest, there's not a ton of information out there yet. But please feel free to reach out to me, and I can hop on the phone to give people an update, or if they want to be engaged, we can make sure that they're kept in the loop on what's going on.
Okay, great. Well, Martha, I really want to thank you for your time. Thanks to Rocky Mountain Institute for having you out here. Please, everybody, continue to join us for our Wednesday webinar series and our ongoing Zero Energy Capable series as of this year. Thanks, everyone, and have a great week.
Thank you.